about this? Breakdown of heme. Red blood cells are destroyed. Halimbawa, naisaman. Or you happen to meet an accident. Yan ay hematoma. What will happen to your red blood cells? Huh? Guys, okay, what comprises your red blood cells? Of course, that contains the protein hemoglobin. It contains the protein hemoglobin. Then you have the heme and the globin. So the globin is hydrolyzed to amino acids to be used. How about, okay, the iron? Iron is preserved in ferritin, which is an iron-carrying protein. And that will be recycled again. And how about the heme? The heme is converted into bilirubin. What is that bilirubin for? It enters the liver via the bloodstream and transferred to gallbladder where it is stored in the bile and finally excreted in the feces. So, ang bilirubin is a constituent of your bile for abdo, no? Which emulsifies fat for fat digestion. Now, ngano kung stool looks like greenish? It's because of this bilirubin. So that it's excreted in the feces. So some will be excreted in the feces. Okay? Oh, manunod na ito ni. Para di na tayo mag-meet sa Wednesday.
Okay.
Mag-meet ba ka Monday?
Wednesday
dito. Hindi naman na Biosynthesis. Synthesis or anabolism. Now, in most living organisms, the pathways that the compound is synthesized are usually different from the pathways by which it is degraded. So, there are pathways which are for the breakdown, and there are separate pathways for the synthesis. So, there are pathways for catabolism or breakdown. There are also pathways for anabolism or building up or synthesis. Now, you have here. Now, these pathways are said to be experiencing or say described as having flexibility. They need to be flexible. If a normal biosynthetic pathways is black, the organism can often use the reverse of the degradation pathway for synthesis. This is what we call as our plasticity. This is described as plasticity of the person. Now, normally, the pathways or the agianan, say padung ka og Cagayan. Padung ka Cagayan is different from supposedly padung ka og Valencia or say padung ka og Davao. Normally, na siya. Say, the pathways for synthesis is different from the pathways for breakdown. However, how we describe the cell then? Now, when something is wrong, say for example, there is sickness that will happen, and that causes then the blocking of that pathways for the synthesis. And that synthesis, or say the molecules that will be formed in the synthesis are very important for maintenance. So how would the cell face that condition? Now, that pathways for breakdown may be used out. That is what we call as flexibility or plasticity. So, pwede na ka from Cagayan, dili na ka moagi og wato kag Davao, supposedly, pwede na ka, halimbawa, na ay MPA dira sa kuan, sa Manolo Fortich. Pwede na ka mo detour, say, dili na wato kag Davao, pwede na ka dili moagi diri sa Valencia or Bukidnon. Pwede na ka diretso dito sa Butuan. Then Butuan, Davao. Get it? Or San Francisco or Agusan. Pwede na ka dito moagi. Okay, tuyok na kaayo. So that is what we call as flexibility. So our cells are said to be flexible. So ang normal biosynthetic pathway is if it is being blocked. Say for example, nadaot tungod sa drugs. Sikag suyok ng drugs. And then ang pathways are being blocked. The pathways for the synthesis are being blocked. So pwede siya ang degradation pathway can be used, or say we call that reverse pathways can be used for synthesis. Are you with me? That is flexibility. Okay? Then another, we have this Le Chatelier's principle, which illustrates this. Say for example, ang glycogen can be converted into, say we have here glucose or glucose phosphate. But say, what is glycogen? This is glycogen is stored sugar for animals. This is polysaccharide. This consists of several units of glucose. So kung gamito na ang glycogen into energy, so pwede siya nga i-convert siya into glucose. So pangputol-putulon na siya. Putol-putulon sa enzyme. So using this enzyme phosphorylase. On the other hand, kung ang glucose i-convert back into glycogen, say for example, sobra imong kaon, daghan kay imong carbohydrates, pagkaon nimo, na kay rice, na kay bread, na kay spaghetti, na kay noodles. So you have produced more of this glucose, of which the cell cannot use yet at that time. So the cell will store it in the form of glycogen in the liver or in the muscles using the phosphorylase enzyme. So, dili na siya mo produce og another enzyme. Iyan ang gamiton ang same enzyme for the splitting and the synthesis. Okay? So, that's why it's reversible. Using phosphorylase. That is what we call as Le Chatelier's principle. Are you with me? Okay. So, that is when the organism experiences blocking of pathways due to some reasons. Okay? So, the cell will opt to go for flexibility, say, using the reverse process, which is, of course, degradation instead of synthesis pathway. So if the synthesis pathway is being blocked, then the degradation pathway will be used up. Or the cell will make use of same enzyme for the breakdown and the synthesis. Okay, para lang yun nga mabuhi to survive in that particular trauma or circumstance. That is how you are made of glass. That is how flexible we are. God knows that men will be abusive. So, when He created us, so many pathways actually, but there is no collision on these pathways. And supposedly these pathways are specific for that particular processes. However, some of these, if they are being blocked, of course we have some spare pathways. We have some spare pathways. So for example, walay glucose. Pwede ang glycogen i-break down. Muagi siya sa dihydroxyacetone phosphate. Nagyapoy pyruvate. Are you with me? So that is another. Okay. So another alternative. Or using this same enzyme. So which shows that our God is a God of mercy. He's a God of grace. God of flexibility. That's how He made us. We have been flexible and we are designed to be overcomers of stresses, whatever stresses or circumstances. That's why He made these pathways in the chemical reactions every day, which can be used alternately or alternatively. Should there be any blockage of other pathways or the alternative pathways. Okay? So you have here, that's the Le Chatelier's principle. Now, most synthetic pathways are different from the degradation pathways. Most also differ in location and in energy requirements. So you have here, like for example, conversion of carbon dioxide to glucose in plants, that is in photosynthesis. Or synthesis of glucose in animals and humans, that is formation of glycogen. Then conversion of glucose to other carbohydrates. So we have this biosynthesis. Photosynthesis takes place in plants. While in green algae cyanobacteria, it uses chemiosmosis.